phrase, in this video, I'm talking about permutation with repetition. At the same time, I'm talking about conditional permutation. Actually, I'm going to solve different questions under this video, but what actually happens is that you guys actually need to know how to identify permutation with repetition, and also when a permutation is conditional. Now, the first question I'm having here is that find the number of arrangements that can be made out of this letter of the word assassination. Assassination is actually a word, let me just say characters that contain different letters in it. But if you look at the word assassination very well, we have how many letters there? We have A, right? We have A as a letter, we have X as a letter, S as a letter, we have I as a letter, we have N as a letter, and we have T. At the same time, we have what? O as a letter, right? So if you look at this very well, we actually have how many letters? We have 1, 2, 3, 4, 5, 6. 6 letters comes together to form the word assassination. But what actually happens is that there are some letters out of these 6 letters that are actually repeated. So in this case, it shows that this permutation question is actually a repetition question, because there are some letters that are repeated in the word assassination. Now let's just go ahead and just fish them out. How many A do we have in this word assassination? We have 1, 2, and 3 A's. So here we are going to have this word 3. This is 3A, right? Then how many S do we have? We have 1, 2, 3, 4. 4S, right? So we have 4S in the word assassination. Then how many I do we have? We have, that's 2I, right? We have 2I. Then how many N do we have? We have 1 and 2. That's actually 2N, right? Then how many T? We have 1T. And how many O's? We have what? 1O, exactly. So what we are going to do in this case is that we are going to follow the rules exactly. We are going to follow the rules and we are going to solve it. So what we are going to do is that we're going to count all these letters all together. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is 13 letters, right? So here our N is going to be what? 13. Then in this case, we are not going to have a single R, because they are actually a repeated permutation, right? So now we are going to use the formula. That's n factorial divided by what? N1, right? Then n1 factorial, then n2 factorial, exactly, then n3 factorial, and so on. So here I'm going to have what? N factorial. What was my n? My n is actually, that's 13 factorial. N is going to be the total number that are present, the total number of letters that are present in the word assassination. Then divided by my A. What's my A? We have 3 A's. So here it will be 3 factorial. Then we have how many S? That's also actually what? 4 factorial. Then how many I? That's 2 factorial. How many N? It will be 2 factorial. Then how many T? 1 factorial. How many O? That's actually what? 1 factorial. That's how it's going to be. Your N1, N2, N3. The N, where the N represents the number of the repeated letters. Everything here is going to be 13 factorial divided by what? This is 3 factorial, but I'll pick 4 factorial because 4 factorial is what? Is the highest. Then I'm going to have 4 times 3. Times 3 is down. 4 times 3. Then I can just say multiply by what? Multiply by, let me just say 4 times 3. Multiply by what? That's 2, right? Then multiply by what? That's 1. That's for my 4. Then for my 3, I'm going to have multiply by 3, multiply by what? 2, exactly. Then multiply by what? 1. Then for my 2, multiply by what? 2 times 2, exactly, times 1 times 1 times 1 again times 1 again. It's somehow long, held the best. This first one represents these 2. This second one represents what? For these 2. And the one factorial that we have, which are these, right? So I can actually go ahead and simplify this. If I don't want it to be like this, I can just try to simplify it further, so that I can have it to be 13 factorial divided by what? Divided by, that's actually 4 factorial first. You know, everything here is actually 4 factorial, right? Then I can just go with multiply by 3, multiply by what? 2, right? Then what do I have again? Multiply by what? 1, exactly. That's for my what? My 3 factorial. Then the next thing I'm going to have to what? 2 multiply by 1, then multiply by 2 multiply by 1, exactly. So this for is for my 2 factorial, this for my 2 factorial, this for my 3 factorial, and this for my 4 factorial. Why do I do that? It's because this 1 and 1 factorial and also 1 factorial is still the same thing as 1. Right? It's still the same thing as 1. So now let's go ahead and solve this. So 3 multiplied by 2, that's 6. Multiplied by 1, that's actually 6 again. By 2, 12. By 1, that's 12. That's 24. So here we have it to be 13 factorial divided by what? 4 factorial. Then times what? 24. Exactly. So here I should have it like this. My 13 factorial, that's going to be what? That's going to be 13, right? Then multiply by what? 12. Multiply by 11. Multiply by, that's 10. Multiply by, that's 9. By 8. By 7. And by what? By 6. By 5 again. By 4 factorial. Divided by what? That's actually 4 factorial 24. Then this cancel this. So pressing everything here on calculator divided by 24. The answer is going to be 10. That's 810,800. Wow, all the best. The answer is long. So you press everything here on calculator, you're going to have to go 10, 810, 800. So now let's move to the what? To the next question. So guys, the next question I'm having here, the question says find the number of ways in which letter of the word school can be arranged. Now we are now given the first one. If two O's must come together. 2. If two O's must not come together. So what this question actually means is that this question represents a conditional permutation, since we are given two conditions here. The first one is that if the two O's must always come together, and the second one is that if the two O's must not come together. Now the first thing is that we have the word school like this, right? O-O-L. Now if we remove these two O, because these two O, they are the one giving us condition, we are going to have it to be S-C-H-L, right? Now the first question says if the two O's must always come together. Now if two O's must always come together, let's just take the two O's as just a single thing, like as a single letter. You understand what I'm saying? Like as a single letter. Now we are going to have S-C-H-L. If you take these two O as a single letter, that means we can fix them here, right? This is the first place. We can put them here, the second place, put them here, the third place. We can put them here. This is the first place, and also we can put them here. So we can arrange the O here. Let's say we put O here. We can also as well put it here, as well put it here, as well put it here, as well put it here. So the number of ways here is actually 1, 2, 3, 4, 5. So this is 5. Then multiply by how many numbers do we have left after removing all the whole? We have it about 1, 2, 3, 4, which is 5 multiplied by 4, right? And 5 multiplied by 4 now in this case is it going to be just ordinary 4 or 4 factorial? In this case, I'm going to have this 4 factorial instead of just 4, because I can choose to fix the A using this arrangement, or I choose to fix the 0 rather using this arrangement. I can choose this arrangement to fix the O, right? So this should be hell actually. So that's just how it goes. So what I'm now going to do is that this is 4 factorial. I'm going to have 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1. So this is 120. So that's 120 ways. So there are 120 ways through which I can arrange my O's when if they must come together. There are 120 ways. So now the second question says if the two O's must not come together. Now if the two O's must not come together, let's take this one as an example. If I should fix the first O here, that means I'm having 1, 2, 3, 4 other ways through which I can fix the second O, right? So if I continue like this, it shows us I have 4 factorial ways. That's the first thing of fixing the second O. I'm having 2 O here. I fix the first O. That means I'm having 1, 2, 3, 4 left for the second. But for the first, how many ways do I have? I have 1, 2, 3, 4, 5. That means for the first, I'm going to multiply this by 5, right? And total number of letters that are here is actually 4. Then I'm multiplying this by 4. All divided by how many O do I have? I have 2 O's, right? Then here I'm having divided by 2. So this simply means this is actually 4 factorial multiplied by 5 multiplied by that's 4 5 multiplied by 4 should give us, that's actually 20, right? So divided by what? 2. So this cancel this, right? Then I'm having 10. Then 4 factorial is actually 4 multiplied by 3 multiplied by 2 multiplied by 1. That's actually 12, 24, right? And this is actually 240 ways of arranging them if they are not going to come together, if they are not going to appear together. That's just it. So let's move to the last question. Exactly. So let's check the final question I'm having here. The question says, how many different numbers of 5 digits can be made using digits 33445? So if you look at this question is actually a permutation with repetition question. So you just have to go with this. How many numbers do we have? We have 3, right? We have 4 and 5. Then in this, from these digits, how many 3 do we have? We have 2 3. We also have, that's actually 2 4s and also what? 1 5s. So here let's count the total number of each of all the digits. That's 1 2 3 4 5. So in this case, I'm going to add what? 5 factorial divided by, instead of writing 3, I'm going to put 2 factorial, 2 factorial, and also what? 1 factorial, right? So this is simply 5 multiplied by 4 multiplied by 3 by 2 factorial divided by what? 2 factorial, 2 factorial. 1 factorial is actually what? 1. So this cancel this. I'm going to have 5 multiplied by 4, which is 20 by 3. That's actually 30. So the answer is actually 30. So if you enjoyed this video, please do well to what? To like and share, and don't forget to what? To subscribe to my channel. That's the only way you can what? Help this academy. So if you have any question that you want me to solve for you under this permutation and combination, you can just drop it in the comment box below. I'll be there to reply you. Thanks for watching.